So the way the presentation is going to happen, Jay and Sheldon are going to join us here in a second. They'll be turning on their cameras. They're going to present for a little bit. We're going to have a short little 5 to 7 minute break for some Q&A kind of in the middle. They're going to finish their presentation, and then we'll have a longer session for Q&A. Use the Q&A feature on Zoom, if you would, to submit your questions, and I'll be asking them of our presenters. And what's either going to happen is we're going to get to 3:30 here in Manitoba, and we're going to run out of time, or we're going to run out of questions, at which time we will end our webinar. So and with that, I'm going to ask Sheldon to join us and start his presentation. And thanks for doing this, Sheldon.
Yeah, of course. Just start with a quick introduction. So thank you for inviting us. My name is Sheldon Zimmerman. I'm the director of the automotive vertical here at OTTO Motors. And with me, Jay Judkowitz is going to join and do a quick introduction of himself as well. I myself come from an automotive background. I spent 25 years doing industrial robotics for automotive customers. I joined OTTO Motors about 1 year ago to take on the automotive vertical, and happy to be here to present on the technology for the team on the webinar.
Hello, everyone. My name is Jay Judkowitz. I've been at OTTO for 3 years, where I serve as the VP of product. The product team at OTTO defines the products that engineering builds. We make sure they get out the door on time and under budget, and then we share technical information about these products to the world in forums like this. I've been doing product management for 18 years, and I've had long stints at companies like VMware and Google Cloud. Most of my career was in Silicon Valley, but I moved to Kitchener, Ontario in 2017, and I joined OTTO in late 2019. I'm really happy to be here to answer all your questions about AMRs generally or OTTO specifically. Thanks a lot for making the time.
Thanks, Jay. We should have my screen visible for everyone. Just want to double check, Ron, that that's the case.
It is there.
Okay. Well, thank you again. And thank you to Ron and VTCI for setting this up and organizing the webinar on our behalf. I'd also like to thank the members that took the time to join us today to learn about how OTTO Motors can assist in automating Manitoba's heavy vehicle material handling operations. So without further ado, I'm going to skip over just the next slide because it was our introduction slide, which we've just covered. But again, Sheldon Zimmerman, Director of Automotive Vertical, and Jay Judkowitz, VP of Product here at OTTO Motors. Just a quick overview of the agenda that we want to go through for the presentation. So we want to provide an overview of the market challenges that the heavy equipment and vehicle manufacturers of Manitoba are facing. So we'll start off with that. We then dive into the OTTO Motors technology offering and give you a thorough overview of our AMRs, our autonomous mobile robots. We'll then break for a Q&A period with Jay, as mentioned. Following that first Q&A, we're going to showcase some real-life applications of our AMRs at work with end users in the manufacturing space. We'll provide an overview of the software that powers our robots. It's known as Fleet Manager, and we want to dive into the power of that software offering. Next, we'll go over the service and support offerings that we offer for your deployments. And then again, as mentioned, we'll do a final Q&A period. So just starting to talk about the market challenges. Canada's labor shortage problem is evident. And when you look at the heavy vehicle manufacturing in Manitoba, it represents 11% and accounts for $1.5 billion in annual exports. So the industry is strong. However, there are labor shortages, late fees, and delayed capital investments. In fact, Canadian Manufacturers and Exporters, CME, has put a number on worker shortages of $13 billion. That's how much the current labor shortages are costing the industry across the country in the last year alone. The CME, they came to that total extrapolating from a recent survey of its members on labor force issues. It comes from lost orders because companies don't have the workforce capacity to take on more work. and from costs that they have to pay for expediting to deliver when things show up late. Jill Nags, an official with CME Manitoba, said there's no reason to think Manitoba manufacturers are not bearing a proportionate share of that $13 billion that's being left on the table in the past year. It's been the number one concern for Manitoba members for a few years now, is what she said. Also, Stats Canada on September 20th, just looking at the chart in the bottom left of your screen, on September 20th, Stats Canada said there were nearly 1 million unfulfilled positions in the second quarter, and that's the highest quarterly number on record. That's also up 45,000 vacancies from the prior quarter and is 42% higher than in 2021. So a huge pressure on manufacturers trying to find labor for their facilities. So why automate? You know, that becomes a question that's quite often asked. So we've highlighted some of the main reasons that people are looking to automate the material movement through the use of AMRs. The first, and mentioned already, is labor shortages for material handling roles, with an increased difficulty in finding really qualified talent. In fact, US manufacturers are saying that there will be 2.1 million unfulfilled jobs by 2030. So not only is the labor shortage real today, but people believe it will exist for a long period of time, and that it's not just a COVID impact that's going to be eliminated over time. This is something that's here to stay. Rising labor rates resulting from the smaller labor pools, right? Just a cause and effect. And then traditional forklifts pose a workplace safety risk. In fact, 35,000 serious and 62,000 non-serious injury accidents per year in the US. And 11% of forklifts are involved in accidents annually. The last point here is market demand for forklifts continues to increase due to the logistics pressure from changing buyer behaviors and consumption trends. So let's talk a little bit about safety. Traditional material handling is dangerous. 90%, there's a 90% chance of a serious accident occurring during the 8-year average lifespan forklift. And 2 of 5 people working in warehouses get injured because of manual material handling movement. And lastly, 502 accidents by industrial vehicles caused 77 fatalities in the US in 2017 alone. Traditional material handling is also expensive. Labor costs are a warehouse's largest expense typically. And 33% of an operator's salary is turnover. Costs associated with onboarding, training, and hiring processes add to that factor. More than 80% of Canadian manufacturers have faced serious labor shortages in the past 2 years. And in the global manufacturing industry, there has been over 73 billion in unrealized output due to this labor shortage. And traditional material handling hasn't changed much in 30 years. And you know, I wanted to highlight a little bit of what that looked like in the past. And that's, you know, on the far left, you see manually delivered material by people, by pallet jack, or by forklift. The pros of those systems being that they're flexible, they're dynamic, they're scalable, and they're resilient. The cons are it's low throughput, it's high operating cost, it's unpredictable, and it's prone to errors. Then you move into more of the automated material movement, whether it be by conveyance or crane or even AGV or automated guided vehicle. The pros of that is it gives you high throughput, it's low operating cost, it's very predictable. However, it takes up a large footprint in your facility. They're difficult to reprogram. They're not flexible traditionally, and they have a high capital expenditure cost. So the AMR industry that we're going to present today, we feel takes the pros from both of these material handling methods and offers them in an AMR solution. So I'm going to go over the next section of our presentation is to go over the OTTO Motors and AMR technology overview. This is just a quick GIF of a trade show that we presented at IMTS in Chicago, just showing some of the vehicles moving around the demo space, but I'm going to dive into our technology offering now. So what is an AMR? An AMR, it stands for Autonomous Mobile Robot. We find often that people use the term AGV or Automated Guided Vehicle to include our technology. And there are major differences in the technology and how it functions. AGVs, for instance, follow a set of instructions and execute them. The ability for them to adapt on the fly to surprises or changes is very limited. In contrast, AMRs are flexible. A true AMR will have a map on board, receive a destination waypoint from the server, and make its own decisions on how to navigate to that waypoint. It can change its mind, plan alternate routes, or adapt to the current situation. It will keep trying to accomplish its mission until it becomes completely or physically blocked. And they're meant really to help fill that labor gap that I mentioned earlier. And they're meant to keep people doing value-added work rather than doing work that doesn't add any value to your end product, which is material movement. Again, just to elaborate on this difference between an AGV and an AMR, on the left side of the screen, you see a description of what is an AGV. It behaves much like a conveyor. It's pre-programmed, relies on physical infrastructure such as magnetic tape, wires, or beacons, and it has a fixed path. I think of it, if you think of like a city infrastructure, I think of it as like your streetcar, in that it can only follow a specific path. If there's an obstacle in its way, it's going to stop until that obstacle is removed. It's going to move slowly through your infrastructure and stop at every bus stop that is defined. On the right hand of the screen, you see the description of an autonomous mobile robot. It has onboard intelligence, no physical infrastructure required to move and navigate around your facility. It enables machine learning so that the robot becomes more efficient and accurate as it encounters new situations. And it behaves much like your material handlers today, like your labor. It operates with flexibility. Of course, we have a little taxi screen there. So in a city example, it's much like a taxi. I think of it more like Uber, where the pickup points can be dynamic and change. The drop-off points can change as well. And even the path to get there can change depending on traffic and that sort of thing. So I use the Uber analogy. I think we need to update our slide deck with the Uber symbol. So we, as mentioned, we are a Canadian company. We're a leading provider of autonomous mobile robots. Recently, it was announced that the company had been named as a member of Team True North. Team True North is a proactive data-based initiative by Communitech. It serves to identify the country's highest potential tech companies and strengthen the entire Canadian tech ecosystem. Companies recognized as part of Team True North represent the top 1% of Canada's highest performing global private companies. And just a quick quote from our CEO and co-founder, Matt Rendell, who you'll hear from later in the presentation. We're honored to be named to the Team True North and to be the only robotics company on the list for 2022. In the past few years, we've seen automation transition from a tactical initiative to a strategic one. And this recognition by Communitech speaks to the growing importance of automation. We're proud to be among this year's winners and help keep the economic wheels turning in Canada and around the world. So OTTO is quickly becoming one of the largest indoor logistics operators in the world. If you think about a typical forklift driver with, say, 20 years of experience, they have approximately 42,000 hours of driving experience on your forklift. Each of our AMRs has the collective experience of 4 million hours in a production environment in mission critical operations. So every one of our AMRs benefits from the experience of every other AMR out in the world. We perform 400,000 deliveries every month. And of course, as we grow as a company, that number is also growing exponentially. 70% of our autos are deployed within Fortune 500 companies. And I'm going to share a list of those. It's not all of the companies we work with, but certainly a short list of Fortune 500 companies we have done business with. And in 13 years of operation, we have had 0 safety incidents with our AMR technology. Our founders actually sit on the ANSI board that regulate AMR safety for all organizations in the industry. So in that respect, we set the standard for safety. So here's a short highlight of some of the organizations we've done work with. From the heavy equipment industry, I'm sure it pops out off the page, but Caterpillar is certainly one of ours. John Deere is also a customer of ours. And then later in the presentation, you'll actually hear from some of the companies that are on the screen. We have quite a few case studies with the companies we've done business with. They volunteer to do the case studies with us, and the video benefits both them and us in presenting how the technology has benefited their operations. The next slide is an introductory video of our technology, so I'm just going to play that for you now. That was just a quick introduction of the product offerings. I'm going to dive into more detail on each of the products in a moment, but I want to start off with the platform itself. We really think of the OTTO Motors platform as existing within 4 main pillars. The first, in the top left of the screen, is the obvious, the physical robot or hardware that's performing the material movement in your facility. The second is the onboard AMR operating system that provides the intelligence required to navigate through your facility and ensure deliveries happen at the right place at the right time every time. The third, if you go to the top right of the screen, is the fleet management system, which we will dive into in more detail. But it manages the map and job creation, job assignment to each of the robots, the charge rate of each of the robots, and other key features like alerts and data analytics. The fourth pillar is professional services and training. We like to wrap up the entire product offering with world-class training solutions and service offerings, because enabling and supporting our customers through their operation is key to our collective success. So let's look at the robots themselves. So this is the fleet of robots that we offer today. Of course, a technology company like us, we're always looking to expand our fleet and expand our offerings, and that roadmap is continuing to evolve. But on the far left, I call it our little tank. It's called the OTTO 100. It's small and agile. It's perfect for human scale loads up to 150 kilograms or 330 pounds. A lot of customers use it for tote delivery or human to human delivery via cart. The second vehicle next to it is the OTTO 750. It's used for automating your tugger or pump truck delivery routes. It's nimble, yet still carries a payload of up to 1,150 kilograms or 2,340 pounds. And then our heaviest payload vehicle, which is the OTTO 1500, is the third vehicle on the screen there. It's for automating your heavy equipment delivery routes. It's durable for demanding applications and can carry up to 1,900 kilos or 4,200 pounds. Our newest offering just came out in March of 2022 is the OTTO Lifter. It's for automating your pallet transport workflows and moving pallets from the floor to a stand, or from a stand to the floor, or from conveyor to conveyor. And it's intelligent and predictable pallet transports of loads of up to 1,200 kilos or 2,640 pounds. Just to key in on the forklift itself, we consider it the smartest autonomous forklift in the industry. It has intelligent pallet detection for skewed off-centered pallets and stretch wrap covered entry notches. One-touch autonomous lane clearing, which I'll show you in a video in a second. It utilizes what we call adaptive field set technology, which maximizes your speed while maintaining safety in the facility. Of course, it utilizes the same single fleet management system that all of our vehicles utilize. So they all run on one software platform, and it continuously remaps zones for dynamic environments. This is an example. I'm just going to let it play and I'll just narrate it. There's no audio to it. This is Omar. This is at the IMTS show that we were at recently in September of 2022 in Chicago. And this is showing just the safety and the ease and comfort of Omar as he walks around the robots and amongst the fleet. And you'll see an interaction coming up between the lifter and our OTTO 1500, which is in the background there. So really just showcasing how comfortable it is to be around these robots and some of the re-navigation that the robots do to get around obstacles or people in your facility. In a second, he's going to knife right through the middle right there between the two vehicles. Again, always monitoring the obstacles that are in their way and trying to find an efficient method to get around them. Again, I think that one's powerful. I just want to talk a little bit about it because we set up these trade shows in 2 days. And we feel comfortable enough with our technology to bring it into a trade show, set it up on their floor, have our people or even people within the trade show come in the fence lines, walk around the technology, and be safe. And I think that speaks to the trust we have between our product and really putting it out there on the floor within a short period of time. Okay, Ron, I think that is the first break.
Awesome. Awesome. So we have one question that came up, and feel free to submit more. Joshua asks, you claim the forklift robot will continue to do its task until it's physically constrained from doing so. How does this affect the collaborative ability to working in and around these robots? How can you ensure the robot will not collide with plant workers? And I think that video that you just showed illustrated that well, but I think Jay, you had a couple of comments you wanted to make.
Yeah, absolutely. That couldn't have been timed better, the question asking on the last slide before Q&A. And I think that video is important because anything I tell you, I mean, it's going to sound reasonable, but the reason you should believe me is because we did video, right? There was 100,000 people at that show, and if anything had gone wrong, it would have been, obviously, quite reputationally damaging. So, I mean, that shows the trust that we have, and the trust that Omar had, right? You look at the smile on his face as he was doing what he was doing. But as for the technology, how we get it done, basically the key ingredient is a LiDAR, a laser scanner essentially that works out on a plane, and it basically, sprays laser all over, finds out where things are, and the closer it gets to things, it either slows down or stops. So if it sees something far in the distance, it might go fast. If it sees it closer, it'll slow down, and if it gets too close, it stops. And the LiDAR and the PLC system that controls the field sets and lookups, that's all safety rated. It basically rated PLD level safety rating. So it is, incredibly safe. And like Sheldon said, we've never had a situation where, we misfired and somebody got injured. We have additional safety features on top of that. For example, we have 3D camera, which will look above and below the plane, which will further help with obstacle avoidance. But yeah, I mean, that's basically the safety system. And so while there is a lot of sophisticated software on the robot, that, like I said, that safety system is that PLD rated hardware. The software physically cannot tell the robot to do something that is unsafe. Like if somebody just wrote a horrible bug that said, drive as fast as you can at the nearest obstacle, the hardware would stop it from doing so. And so that's how we, guarantee safety.
That's perfect. And Kevin actually had a question that came to my mind. I've got it written down here on a piece of paper right beside my computer. How does the lifter robot, which I would assume is the auto lifter, know the physical extent of the product that it's lifting? How would it prevent dropping an oversized, regular sized object onto a worker's toes, or navigating knowing that the front of the pallet is 39.5 inches from the front of the unit?
Sure. So one thing is we do have a compatibility matrix of what we support, right, payload wise. And so you wouldn't want to just, like, there are pallets that we support like CHEP and PICO and GMA, and that's what we support. Now let's say there's a payload hanging off the end of the pallet. That would be non-standard, and we would create a custom field set for you. And that field set, again, is what's being enforced by the LiDAR and the safety system. We do have additional sensors on the forklift besides the LiDAR and the cameras that basically check pallet placement and make sure that the pallet is not too far ahead or too far behind or too far left or right so that it tips. So there's just a lot of sophisticated sensors around the times and the lift to make sure we're picking up the right thing. But basically, I think one thing that might be behind the question is, like, don't lie to us, right? If you tell us that you're going to be picking up pallets that are within the pallet, but the payload hangs off 10 feet to the side, bad things are going to happen, right? So while we have a ton of safety features in the products, it doesn't absolve people from, setting up things correctly.
Yeah, interesting. Great question there, Kevin. Thank you. This one's an interesting one here about the ethical issues about having your founder setting the safety standard. And interestingly enough, I was part of a conversation on this morning, is that sometimes technology outpaces the ability for regulators to develop rules around things. And it takes the developers of the technology to be the ones to set the standards, because the regulators don't really. How do they set regulations around something that they don't know? Any comments there?
Yeah, just to be clear, I mean, that's an ANSI standard, the RIA standard. So it's not the kind of thing where, we just threw something out there and said, we're the leaders. There's a lot of eyes on that, from both us, our competitors, and other interested parties. But I think, what Ron said is the thing is, if you don't have people that are working on it, you can't, it's not commodity yet. It's not the kind of thing that somebody can come off the street with an opinion about. But I would say also, because we see ourselves as leaders here, by being a part of the standard, we don't have an incentive to weaken the standard and create a safety risk. We actually have the opposite incentive. Our incentive is to make it as ludicrously safe as possible. To raise the bar for competing. I'm not saying we do that, right? That would be another ethical problem. But the idea is, just in case you're wondering where our incentives are to protect the technology and protect our reputation. We don't want a million competitors coming in and running people over, and then everybody goes, oh, AMRs aren't safe, right? We want this to be the most trusted technology out there. So if you're worried about potential ethical conflicts between our business interest and safety, I'd say it's the opposite. Our ethical alignment and business alignment are focused exclusively on your safety.
Oh, perfect. Thank you. That's it for questions right now. So Sheldon, if you want to continue, go right ahead.
Sure. Thank you. Just shut off the video again. Thanks again, Jay. I was so raw to the presentation. Okay, so the next part of the presentation is really to walk through the AMR use case and some real life examples of how these robots are utilized in industry. We've broken the presentation up into 3 types of material movement. The first is to and from people. The second is to and from floor racks and stands. And the third is between islands of automation. So say a sub-assembly cell to a main line. Of course, any combination of these types can work too. You can go from people to an island of automation. It's just we've compartmentalized the workflows into these types, and we're going to go through a few examples of each. So the first is bringing materials to and from people. So this is a real life example of a tier 1 automotive supplier in Michigan, Faurecia. You may have heard of them. They wanted to move automotive components in stacked totes. You can see a quick GIF file of that movement, but I'm going to show you a more comprehensive case study video we did with them. And they took on 14 Auto 100 AMRs with staging carts. It says red, they're actually gray. And what they were looking for was a reliable, small footprint solution for the timely movement of their materials. And they wanted minimal downtime and minimal hands-on support. And what they experienced out of the back end of the project, and what they're going to inform you in the video of, is they were able to reduce the work cell sizes, so actually gain back floor space in their facility about 15%. They achieved an 11-month ROI on the deployment, and higher response times, leading to an improved efficiency for their operations. So I'm going to let the video play. Again, it's Faurecia in Michigan, and they can tell the story better than I can.
Faurecia is a leader in automation and cutting-edge technology. We do automotive components, instrument panels, consoles, door panels for Ford, GM, and Chrysler. Also BMW, Rivian, and Volvo. With the COVID restrictions going on and people having problems getting to work, we're trying to automate some of the processes so we can reduce our people workload and that we can function as a plant even in these trying times.
We have 8 Auto 100s with brake carts. We will be receiving 4 more in the future. It's happened 1 or 2 times here at Faurecia where the auto has accidentally been hit by a tugger or a high-low. The autos are so robust that if it does take a hit from a high-low or a tugger, it is quick to reroute and complete the mission.
One of the basic problems we're trying to solve is the material movement between the work cell and the warehouse. The autos fit exactly what we need it to do, where it can pick its new path, where it doesn't need a magnetic strip.
I was in charge of bringing autos into the plant. I spent countless hours looking for someone to meet the footprint required by our corporate personnel. And auto stood out. Overall, it just needed to be a self-sufficient system. Auto allows us to reduce our tugger drivers and high-load drivers, utilizing the manpower in a much more efficient way.
So the roles the autos play is the operator, once they are done stacking their totes, they turn around, call the auto with the tablet. The auto will then deliver the parts from Tech Bay over to our shipping warehouse, and it'll drop off a gray cart and pick up an empty gray cart and then bring it back up here to Tech Bay.
The autos have safety features that allow the autos to coexist with both a tugger, an operator, people crossing its path. We've been running the autos for about a year and a half. We had 0 safety incidents.
We have a pretty big facility, so I can't visually see all 8 autos at all times. In Fleet Manager, I'm able to see where the auto is, how long it's taking, but also things change in our plant all the time. I'm able to assist with remapping certain areas, put in an eraser zone, put in another zone, put in new routes.
We wanted something that was totally flexible, and Auto gave us that ability. In fact, we moved a couple of cells in the plant a couple weeks ago. Within 45 minutes, we had a new parking lot, a new route for the autos. We've run over 15,000 miles with the auto fleet for the last year, and they operate 24 hours a day, 7 days a week, and they don't take breaks, nor do they show up late for work or get sick. We've only had very few downtime issues with the auto fleet itself. Our return on investment for the autos is about 11 months.
We can utilize our workforce in a much more efficient way. The operators absolutely like the autos, hands down. They actually prefer autos to the old delivery way. It's really a no-brainer. We are expanding the fleet due to being noticed for efficiency gains.
Auto delivers safety, productivity, and efficiency at per sale.
Okay, so just moving on to the next type of material, we're going to look at bringing materials to and from racks and stands. The next couple of videos kind of highlight our autonomous forklift, again, known as auto lifter. The first one highlights our ability to quickly and efficiently perform lane clearing. This next video is going to be stand to floor workflows, again with the lifter, just showcasing its capabilities. Apologize for that. So the third type of movement we're going to look at is bringing materials to and from, or sorry, second type of material movement is bringing material to and from automation equipment. Sorry, that's number 3. Oh my gosh, I'm getting lost. So this is, linking up islands of automation within your facility. First case study that we want to showcase is with Mauser Packaging. There's 2 facilities, one in Langley, British Columbia, and another in Oakville, Ontario. The payload that we were moving is rigid plastic containers. We installed 4 Auto 1500s with side loading conveyors. And the reasons they were looking to implement was manual labor intensive processes drove up their operational costs. It put physical strain on their workers, and the traditional AGV system was failing to meet the required uptime and throughput to run their 24/7 operation. What they experienced was an efficiency throughput of 600% increase. They had 3 laborers reallocated to higher value-added roles, and they reduced the need for 2 additional forklifts, of course, improving safety at the same time. So the next video is going to highlight that installation.
Mauser values innovation because they want to be the leader in the plastics manufacturing industry.
We manufacture pails, lids from 1 gallon to 13 gallon. We service a lot of different industries, Stallbush and Saputo, big customers that put a lot of food product into the pails. This facility is about 206,000 square feet, and we have 140 people working right now. OTTO came into our mind because of the safety concerns that we had in the past. Finding people was very difficult because we were a 24/7 operation. When the OTTO was first introduced to the Langley facility, it was the first step for us to get into something probably nobody's ever done before.
The OTTO arrives to the station, connects with the pack station and transfers the package onto it, and then drives back to the drop-off station where it transfers onto the wrapper-strapper line.
When we introduced the OTTOs, we didn't have to worry about people getting hurt. For the last few years, it became apparent to us that, how important that was. The job that OTTO's doing right now is basically the work of 3 people, plus the additional, at least 2 more forklifts. It definitely helps us out to have that money spent somewhere else.
I was pleasantly surprised working with the OTTOs. Such an easy system to work with. Myself, I'm not that technical minded and work with computers too much, but I found that this system was easy to understand and navigate through. Because the units work so well here in Langley, they decided to expand that and bring the OTTO units into our Oakville plant in 2021.
OTTO delivers safety, reliability, and productivity at Mauser 24/7.
Next case study I wanted to showcase for you all was more of a heavy payload application. This one is Sunview patio doors. You can see on the right just the video file showing us moving 8 patio doors. Again, the footprint of the payload can be larger than the vehicle itself. It doesn't have to stay within the footprint. And this is an example of where Jay had mentioned earlier that we can set up custom safety field sets so that it then virtually sees itself as larger than it actually is. This one was a single OTTO 1500 AMR integrated into their facility in Mississauga, Ontario with an integrated lift. They needed a flexible solution that would help transform their production to a lean manufacturing model. And it was necessary to increase safety and keep up with their evolving market, which required lower price points, faster delivery times, and more customizable products. They experienced 100% safety rating, which was a real goal of theirs, and they're going to highlight the safety aspects of the OTTO AMR in the next video. They achieved a 16-month ROI. They standardized their processes, and again, they shifted skilled laborers to higher value-added tasks.
I'm Kurt Oberparleiter, the VP of Operations. As OTTO drives, it uses LiDAR sensors and stereo cameras to map its surroundings, detect how far away objects are, and replan paths so it can safely navigate around obstacles autonomously. As you can see, Maunick and Harris are blocking OTTO's path. Let's watch how OTTO navigates around them. Even if Maunick jumped right in front of OTTO, I have no concerns about a collision because OTTO is smart enough to react, just like a human would in the same situation. Millions of laser beams are projected 160 feet in front of OTTO, which form a detailed image of the environment in which it is driving. This is one of the ways OTTO ensures it will continue to reach its destination in the most efficient manner without the need for magnetic strips or other infrastructure to guide it.
So just a quick video to highlight the safety improvements and safety aspects that Sunview was, oh, that was not what I meant to do, that they were looking for. Goes to the current slide. Good. Apologize for that. Okay, so we're on to the next part of the presentation, which really focuses on our OTTO Fleet Manager offering and our software. So OTTO Fleet Manager is our enterprise scale AMR fleet management software. It's meant to manage your fleet of OTTO AMRs, and it's the smartest fleet management software, and it's the most scalable for your material movement in the facility. It applies custom traffic rules to your facility, and lets Fleet Manager enforce them across your fleet, while a built-in job scheduler automatically assigns jobs in a way that maximizes robot utilization and material throughput always. It's flexible enough to easily integrate with your existing mission-critical factory tools and systems, and PLC ready to collaborate with your smart factory equipment. OTTO Fleet Manager is designed to help you get started with material handling automation or go full enterprise scale across your entire operation. Our CEO and co-founder, Matt Rendell, recorded a presentation that highlights the benefits and power of Fleet Manager. And this next video is a thorough walkthrough of that offering and the benefits it provides your facilities. I'm just going to let that play next.
Hello, and thank you for joining us at 2021 ProMat DX. I'm Matt Rendell, CEO and co-founder of OTTO Motors, and today I'm very excited to share with you a little bit more about our Fleet Manager offering. First, let me just quickly calibrate you on what we call the OTTO Motors experience, which is an end-to-end journey that we embark upon with our partners and our end users to help ensure a successful implementation of large-scale AMR fleets inside of their operations. We view the relationship starting at the design, the concept of what an AMR solution can do. And in pursuit of that, we partner at the process level to design not only what the AMR fleet needs to look like, but also minor changes upstream and downstream to ensure there are no bottlenecks that emerge once the AMR fleet is implemented. And we call that our design phase. Once we've successfully identified a compelling ROI case for an AMR solution and have the solution designed to back it up, we then progress into implementation, which we call the manage phase. And this is where we commission a large scale fleet, and I'll be talking about that shortly. And then finally, once the solution is implemented, full lifecycle management requires a robust capability for monitoring. And again, we'll be discussing a bit of that today. So in summary, design, manage, monitor is the way we approach successful AMR implementations. And I would encourage you to speak with our team in our virtual booth or engage in a phone conversation with us to learn more about how OTTO can be used in your operations. So let's start by talking about manage. And this is how we achieve enterprise scale ROI primarily through the use of software. Our enterprise scale fleet management software offering is a comprehensive tool that allows large scale AMR fleet control. It allows you to scale up from managing a single auto in your first implementation all the way up to hundreds of vehicles, all from a single device or a single factory control system. And this can all be done easily and securely. Things like fleet configuration and administration, job dispatch and scheduling, AMR fleet monitoring and reporting are all applications that exist inside of our fleet manager. Second, AMRs fundamentally have the ability to dynamically map and path plan in their environments. Using onboard sensors such as cameras and LiDARs, every auto AMR is able to collect information in real time of its surroundings and use that information to make real-time changes to the facility and the map, as well as make dynamic decisions about how the path should be altered to ensure the right part gets to the right place at the right time, every time. When these types of events occur, this information is then distributed to all vehicles to ensure all vehicles are informed. And then finally, all of this is updated in real time to a centralized map view for all operators to get a comprehensive view of how their operation is unfolding. Third, a successful AMR fleet requires smooth traffic flow and traffic enforcement. And that's one of the primary responsibilities of our fleet manager. We have tools that allow you to customize traffic rules and patterns to ensure efficiency inside of your fleet. The fleet manager enforces these rules to help ensure that your materials keep flowing smoothly, safely, and efficiently. We have zone capabilities like speed limits, do not enter, proceed with caution, intersections, priority yield, narrow lanes, one-way traffic, and even defining pedestrian heavy areas. Each of these rules sets a specific behavior expected of your AMR fleet. And these rules are often already codified in your operation and expected of fork truck drivers or other vehicle drivers, as well as your pedestrians. And so we've simply created a simple, easy to use way to codify this inside of Fleet Manager and expect the same behaviors of your auto AMR fleet. Fourth, our scheduling and dispatch applications are critical in ensuring the right part gets to the right place at the right time every time. Our scheduling and dispatch capabilities automatically schedule and dispatch the right work to the best fit vehicle for the job. In doing so, at the fleet level and over a long period of time, this ensures maximum efficiency and ROI of your AMR network. Things like battery charge, proximity to work that needs to be done, what needs to be picked up, how big is it, how far does it need to travel, what does the queue of work look like behind it, as well as what are the attachments for interfacing on board each of the respective vehicles in the fleet, are all important inputs into the scheduling algorithms that our fleet manager utilizes. Fifth, our fleet manager offers a robust set of APIs to ensure factory connectivity and integration, so you can streamline processes upstream and downstream from your AMR fleet. Your ERP integration allows you to seamlessly request actions of your auto fleet from supervisory systems like a warehouse management system or a manufacturing execution system. We also offer an industrial API via OPC-UA protocols, which allow for PLC network integration so that an IO event on the factory floor can trigger a job. And also you can have safety interlocks between your auto fleet and your factory side automation. Our fleet manager has a REST API and a WebSocket API for WMS and ERP integration. 6, our fleet analytics help ensure autos are performing productively and improving over time. We want to enable you to achieve top performance of your fleet. And achieving peak performance requires a deep understanding of vehicle status, jobs in progress, and job history as a few quick examples. So our analytics capabilities are really important for process engineers who seek to continuously improve an operation over time. And finally, 7th, smart notifications is an application inside of Fleet Manager to ensure that communications happen the moment a critical event occurs. And this allows us to keep mission critical processes moving flawlessly. In the event of an issue, users can be notified instantly and enable faster troubleshooting, not only through notification, but also with event logs and playback, all in pursuit of minimizing the time to resolution of an issue. Our notification system allows users to configure critical events such as takt time, fleet efficiency, distance traveled, or job failures, as well as what distribution method and what time elapse is permitted before an escalation occurs. Once configured, OTTO will notify you instantly via a mobile text message, an email, and/or a Slack message, as well as an ability to integrate into other critical communication tools that your business relies upon. Our event log and playback capabilities allow our users to easily dig into the details to troubleshoot issues and come to a solution faster. We also offer the ability to quickly and easily create snapshots of these events and communicate them to our technical support team so that we can help participate in an expeditious resolution of the event. We offer Fleet Manager in 2 variations. First, on-site, on-premise, hosted inside of your existing servers, or in the cloud for access anywhere. All in all, we make powering your smart factory and achieving your goal of lights out manufacturing a reality sooner. Hello?
Play twice. I think he gives a real good overview of the power of Fleet Manager and all of the options that it brings in. One of them is mentioned kind of at the back end of that presentation, and that is data analytics. Data analytics are critical to your manufacturing operations because they can help you to improve your efficiency and productivity and even your safety over time. I was saying the other day, gone are the days of grabbing a lawn chair and a stopwatch and sitting out on the production floor and trying to gather up data and tack times and hitting the stop button at the wrong time and hitting reset. And now you can gather all of that within this platform and really dive down and drill down into the areas of the analytics that you want to focus on, so that you can find out where are some of the bottlenecks in your facility. Is it specific to an area? Is it specific to a robot path? And really identify where those areas of concern are and improve them. Just to mention as well, the data analytics come as a base package with your auto, robot, and fleet management software. So they're built in to the package when they're delivered to your facility. This slide just mentions our 4th pillar, which is really wrapping up our deliverables to your company with a service-first approach. We have a program called Auto Care. It's a 3 or 4 tiered program that offers different levels of care and support, whether it's live technical support and on-demand tools and training, or whether you go all the way to having proactive maintenance and on-site repair, where our team comes in and provides preventative maintenance and turns the wrenches for you as well. So we offer a package of auto care as well. The other part that's not mentioned here, but I do want to touch on it, is our enablement program for training. We have a program called Auto University. It has a variety of curriculums that you can participate in, whether it's service and maintenance or deployment training. And it's a well thought out online program, or you can do it in class at our facility. And that's to enable your team members, your service and maintenance techs, any of your engineers in utilizing and socializing the technology within your facilities. Just getting to near the end, just want to highlight that we as a company strive to deliver results. Our goal is to reduce costs for your facility, amplify your workforce, optimize your production, and of course, improve safety. Again, just a highlight of some of the major companies that we've worked with: General Electric, Amway, Caterpillar, Toyota, Celestica, Danfoss, Ford, and others. So as a next step, if you need to get in touch with us, we've just kind of highlighted our best ways to get in touch. One is to my email directly, Zimmerman@ottomotors.com, or you can contact us through the web, or certainly through our 1-844 number, or as well, we have a monthly newsletter that you can subscribe to, or you can follow us on LinkedIn, on Twitter, or Facebook. We'll pass this along to Ron so that he can share it with you as well. I think that concludes the presentation, and we're just ready to take on the final Q&A.
Fantastic. Thank you very much, Sheldon. So looking at, feel free to submit any questions you've got using the Q&A feature here on Zoom. The next question is from Joshua. What's the biggest challenge in this new market? How accessible do you see this technology being in the next 15 years? Will this be reserved for large scale facilities, or can smaller scale businesses expect to afford this tech?
Great. Two great questions in that. First, the biggest challenge, believe it or not, is just the status quo. Change is hard. If you're used to doing things manually or conveyor system, the idea that you're going to have robots running around and making their own decisions and deciding where to drive is can be like, even if you trust the technology, it can still be kind of jarring, right? And it's not just you as someone who runs a plant or who's a process engineer. You have to train the people who are on the ground. And so I would say, when we lose deals, more often than competition, the reason is just status quo, just people, weren't ready to take a leap, or, maybe they didn't take enough factors of the return on investment into account, and and said it wasn't worth it, right? Those are I think the biggest challenges, just because it's new. And then the second part of Joshua's question, I think he's kind of anticipating my answer, right? Because in the next 15 years, how is this going to be accessible? I mean, gosh, 15 years is a really long time. I mean, just think about what things looked like 15 years ago on phones or the internet, right? And then try to predict what 15 years in the future would be. Like, none of us would predict the world we're in now. I mean, that's a sufficiently large horizon. I would say this stuff is going to be very, very commonplace. I mean, it's just going to be, I think you're going to have a reason not to do it as opposed to a reason to do it. I think in that time, you'll probably see a lot more purpose-built robots, where they're able to do very specific things and not just be, flat platforms or forklifts. Like, I think there'll be a lot of innovation there. But in terms of the accessibility and cost, I mean, gosh, this stuff is all getting cheaper all the time, particularly on the sensor technology. So right now, a 2D safety rated LiDAR, is probably one of the primary expenses of the vehicle, right? But what about 3D LiDAR? What about a 3D safety rated LiDAR, right? What's going to happen in 15 years? These technologies are going to be proliferated, and they're going to be commodity, and you're going to be able to have incredibly sophisticated vehicles at the cost of the sheet metal, more or less. So yeah, I mean, this is the future. Is like, it's still early days. It's far enough along that you're, at the risk of sounding bombastic, you're throwing away money by not adopting now. But in the future, you're going to look back and you're going to see this as a stone age.
Yeah, I think just to add to Jay's comments too, if you look at some of the larger adopters of OTTO Motors technology, one of our largest customers is Toyota. In 2017, they started with 2 AMRs. I'm in the process of them ordering their 160th AMR across North America. They have close to 60 in TMMC. Earlier this year, their facility in Kentucky ordered 56, and again, an emerging opportunity for another 50 or so. So we're roaming around 160 with Toyota. So that gives you that factor of scale. Also tells you that companies like Toyota are trusting the technology to do widespread deployment. The other factor that's kind of interesting, and I use it quite a bit, is that the forklift dealers that exist out in North America that are used to selling forklifts to manufacturers and to material movers, and they do the service and support, they're calling us. They're seeing the writing on the wall. So one of our go-to-market strategies is to partner with forklift dealers. One, because it's a great way to expand your footprint and get more robots out in the world. But two, they're seeing the writing on the wall that they're not going to be selling as many forklifts in 10, 15 years. They need a product offering that they can offer as well. And the added benefit to us is that we get service and support all throughout Canada, all throughout the US, without having to manage all of that out of Kitchener, Waterloo, Canada. So If you look at how the forklift dealers are approaching AMRs, it's indicative of where they see forklifts in 10 to 15 years.
Great answers. So this is my own question. Tell me more about the smallest company that you've worked with and how they came to deciding that an AMR was the path to go.
Sheldon, I don't know if you have one. I've got one if you don't.
I mean, we've got lots. I'll let you start, and then if I need to add in some context, we've got lots of companies that do low volume, high mix operations for sure.
Yeah, the smallest company I can think of is a company called Kober. They do printing materials, and they're our next door neighbors. So they're actually one of the very first auto customers back when it was really speculative, not like, the success that Sheldon was just talking about, with Toyota. And they tried it because, we were next door and we were friendly. And they used the Auto 100 with the red cart. I could probably dig up video if given a few minutes. And they drive, these paper goods around. People, it's got a fixed conveyor, actually not the red cart, sorry. It's got a fixed conveyor on top of the Auto 100. People finish their printing, and instead of walking it over to the next cell, they drop it on the auto, and the auto takes it to the next cell on its own. And so people just keep doing the printing work, and they don't have to do carrying of paper around. And so that kind of use case can work for just about anybody. It's incredibly simple to implement. You don't need an ERP. You don't need factory integration. You don't need traffic lights, or it just works out of the box. And so, like Sheldon said, there are other customers like that. Kober is the first one that comes to mind, just because they're so figuratively and literally close to us. If there aren't any other questions, I'll just dig up video and present it.
That'd be good. Yeah, I was just going to say, like, rather than kind of small companies, I think of like that low volume, high mix operation. We were working with a partner of ours out of Michigan who's an integrator, and they took our Auto 100, designed a specific cart around the Auto 100, stuck a cobot on top of that robot, and then the cobot was doing machine tending for low volume, high mix products that were being used in machining centers, CNC systems. Oh, I can hear your audio there, Jay. Sorry. So that was an example of, hey, let's use the AMR to move the cobot around to do the machine tending in this environment. Now, it was a large corporation. It was GE Aviation that had all of these machining centers, but it was all because of this low volume product that they wanted to do. So that was certainly one example. And the other, again, is it's a larger company, but we do a lot of implementations of robots, of 1 or 2 or 3 robots. I'm working with 3 Magna facilities here in Ontario right now. All of them are looking at very simple single robot workflows to socialize the technology in their facility, get their manufacturing and production and maintenance staff up to speed with the technology, and then look to expand upon that. So that kind of pilot and then land and expand offering is what a lot of companies are doing. And they start with a very simple workflow, get it functioning, understand the technology, and then grow from there.
Yeah, I would assume that you guys have, $1 and $2 million companies that are going down this road. You talk about Cat and Deere and those, even though they're doing onesies, twosies, they've got billions of dollars of resources to be able to dig into this. And I would assume that you've got stories from.
Yeah, I mean, Mitchell Plastics around the corner from us in Kitchener-Waterloo is looking to to buy their first 3 robots in their facility. It's a manufacturing facility, but they certainly are not of the Fortune 500 size.
Okay.
So certainly we do, but again, it comes down to ROI, right? So whether you're large or small, it's about evaluating what the costs are of your existing methods, and then offsetting that with what the cost of automating them are. And a lot of times the threshold that we see from organizations is 2 years. If you can get that ROI under that 2-year mark, then it's something they really want to dive in and explore further. If it goes into that 3 or 4 year mark, then it's probably not the right time for that organization.
And that's a great segue actually to my next question here is how easy is it to calculate an ROI and who does it? How do people do it?
Well, we have some tools that we can offer to help companies that don't have them readily available. So we have factors like, the labor, the cost of ownership of, existing material movement methods. But oftentimes, we're supplying the quotation and then the customers are evaluating their internal costs. If they're open to sharing with us their labor rates and their costs for owning their current capital, we're happy to utilize the tools we have to offer an ROI case. In fact, I think there's an ROI option on our website that you can go in. It's very rudimentary, might not have all the options you want, but it certainly gives you the basics. If you want to just kind of get a quick snapshot of what your ROI might look like, you can use the online tool we have on the website. I can send a link afterwards.
Great. And just for, to kind of wrap our heads around how much an auto lifter would cost, if you took a propane forklift today, minus the operator, and a auto lifter, cost comparison, 3 times, 2 times?
Let me put it in perspective. We do it because we're always offsetting labor. So in a 3-shift operation, we've seen ROI cases that get the lifter down to as low as $8 per hour. Now, auto lifter doesn't move as quick as your manually driven forklift. So it's about a 2-to-1 ratio of auto lifters to manually driven forklifts, just because of speed alone. So if you take that $8 per hour and double it, you're kind of looking at $16 an hour versus whatever you're paying your current forklift drivers.
Okay. Excellent. And actually, it's interesting as I got questions down the margin of my paper here, and as your presentation was going along, you were actually answering all my questions. One of them, though, is if I'm in a work cell and I've completed my work and I have something ready for an AMR to pick up, if I think you'd mentioned that there's just a simple IO interface, I could have a button at a station that I would push, and that would call the AMR to come over and pick up whatever it is I've done and deliver it to the next operation. It's not like I have to have it done at 12:31 every day, right?
Exactly. The simplest interface is a kiosk interface, which is basically just an Android tablet, which has a very, very, very small subset of the fleet manager on it, which is the call and dispatch. There's like one button for, hey, robot, come here, and one button for robot, go away. So you hit the button, you load it, hit the other button, it goes. And so basically all of the other features that, the video was showing about fleet manager stripped away, and you just have this 2-button interface on a tablet that you can mount on a stand and have it be your kiosk. Some customers have made it even more complicated, but I'd say more fun. We do have APIs which can be tied into like your ERP system. So there's people that have actually wired physical buttons to call something in software that calls our APIs, and then just hit the physical button and the robot shows up. That's actually really fun to watch, but that's a little more advanced. But the simplest one is just the tablet kiosk interface. It works great, and that's what a lot of the smaller customers are doing, particularly for work cell delivery.
That's great. That's great. So we're approaching the end of the session today. Kevin's asking, can robots transition between indoor and outdoor environments? For example, product is sometimes stored outside our plants and then transitions to an indoor workstation when needed.
Yeah, I mean, I kind of threw an answer there in the chat. The robots that we build are built for indoor use. They're flat grade, no giant holes in the floor, reasonable lighting, reasonable wetness, no slope or very, very small slope. So I mean, it is built for that kind of constrained environment. And we do have a sister division called ClearPath Research under the ClearPath Robotics parent company. And if anybody checks out the ClearPath Research stuff, they have a lot of outdoor robots that are really cool. But when you look at OTTO Motors, it's all indoors.
Good stuff. Good stuff. Well, I'm not seeing any more questions out there, so
I can show you the Cobra video if you want.
why don't we do that? Why don't we do that quickly, and then we'll end right at 3:30.
Jay, just before you steal the screen, I know, Ron, you had said, hey, can you showcase the headquarters at your facility and the robots roaming around? So I just want to give everybody a snapshot. This is a true live shot. Am I sharing my screen still?
Yep.
Of robots that we are testing in our facility. So our software engineers reside here. They're testing out our latest and greatest navigation and fleet management software. Again, it gives you a quick snapshot of the zoning that can exist. In this case, we really try not to be too organized in our facility so that we're hardening the software and really creating as much interaction between the robots as possible. And this, again, is a live view. So this is something that I'm doing from my living room. And certainly as an owner of the vehicle, you could tap into your fleet manager at the plant and see how your operation is doing on a second or third shift as needed. So just, I know, Ron, this was something you wanted to show the group. So I just show you that. And again, you can zoom in, you can edit the map. And of course, you can check on status of the robots, what their charge rates are, and what have you.
Yeah, that was
Neat to see how it adapts its paths. I can see that actually on the screen, how it's making decisions about, no, I don't want to go here, so this is what I'm going to do.
Yeah, exactly. And then here is just a listing of the robots in the facility. And certainly they don't have all the robots roaming around at once, but it does give you their charge rate and what they're currently doing. Are they doing work? Are they queued? Are they shut down by the user? And what have you. And then when you go to Fleet Manager to the configure side, you're able to configure the facility. You're able to configure the schedules and the workstations. So just a quick snapshot. Again, this is a live view of what's happening in our facility in Kitchener-Waterloo.
Perfect. Jay, how long is your video?
Oh, it's just I'll just play a few seconds of it just so you can see it. But I'm glad you noticed that, Ron. I was going to say Sheldon pulled it up at a fortuitous moment. As that's a test floor, that's not optimized traffic, right? Where it's designed to have backups in traffic jams so that all the algorithms test out. And so it was really cool that 1500 came up at two 100s, and right, the 1500 just stopped. One of the 100s went all the way around, and the other one kind of took a shorter path, but it totally unjammed itself, which was, we couldn't have picked a cooler moment for Sheldon to have opened that up. So sometimes you get lucky.
Yep.
Okay, so
Jay, while the video is playing, if you don't mind just typing answers to the two questions that have shown up, I think we're going to have to end before we get to those. So.
Do we want to do the questions instead? The videos.
Yeah, why don't we do that? And then you know what we can do is we can send around
send the link.
The link around to everybody.
Yeah.
So is this strictly manufacturing, or could any warehouse benefit from this? I would assume any warehouse, right?
Yeah, absolutely. Yeah, we factories, warehouses, distribution centers. The one thing is, if you're looking at the forklift, it is doing floor and machine and stand right now. It doesn't like pull things off of racking. So that does limit some of the warehousing workflows. But what you're seeing can be used, like I said, as long as the environment is a good environment, like in the conditions I described, you can use it for any workflow.
Great.
Yeah, and those robots, they really thrive in kind of that, we call it the horizontal movement in a building. You might have an ASRS system in a facility or a warehouse or a manufacturing system doing the vertical movement of material. We really thrive in long distance material delivery and along those horizontal routes.
Perfect. And the last question, how would the AMR know not to drive through an overhead door loading bay?
Yeah, it goes back to what Sheldon was showing with the fleet manager there. You put the rules of the road there, right? You say this is an exclusion zone. You will not drive in the exclusion zone, and the robot won't. Under no circumstances will it go into the exclusion zone. And that's really important. You certainly don't want a robot taking a header off of the loading bay and, God forbid, landing on a person. So setting up the traffic rules is really important. The robots will follow those rules.
can
And
interlock with doors within a facility. So if you had a door here, one, we can create, you just saw that robot stop. So we create a red stop sign for the robot. It stops. It can then communicate with the door and say, I'm at the stop sign. Can you open the door for me? Door would open and then it would proceed through. So we do have those options as well. But if you do not want it to go into an area, it's a simple, like Jay said, exclusion zone like this one at the top of the screen.
And as I understand that as your robots are moving around a new facility, it's gathering information and mapping that facility as it moves, and it's storing that information for future decision making, correct?
Yes, so the technology is called simultaneous localization and mapping, which is what the LiDAR is doing. It's looking at the obstacles that it sees in the environment and mapping that onto its understanding of what the map is, so it knows where it is. In terms of whether it is remapping, there's a special zone we have called a remapping zone, where it says, hey, this place that you're going to go into, this is constantly changing. Please update your personal map as you go through it. Kind of an advanced feature, but necessary. You mentioned warehousing before. Like sometimes the pallet layouts are totally different. So the walls are the same and the poles are the same, but the pallets can be all over. And so the robot would slow down. And if you put a remapping zone over that, the robot would slow down, be a little more careful, update its map. And then if it came through again and not a lot of change, to go faster the next time through. So we do have that remapping zone feature for very high change dynamic environments.
That's perfect. So with that, it is 3:30 and we're going to end. Thank you very much, Jay and Sheldon, for presenting. If you have any questions, any further questions, feel free to reach out to either Sheldon or Jay. I'm sure they'd be happy to contact you. And we'll be sending around that link later this week so that you can take a look a little further at the offerings that OTTO has. But hey, totally impressed. Canadian company, you know, George Jetson type technology that's being in use today. Congratulations to you guys and thanks for presenting today.
Thanks so much. We really appreciate you putting this together. From everyone at OTTO Motors, thank you.
All right, everybody out there, have a great afternoon and yeah, have a great day. Bye-bye.